Hey everyone, welcome to the Pre-algebra 8.3 video. Today we are talking about using intercepts with linear equations. So before we get into what intercepts are, let's think about something. How many points are actually needed to graph a line or graph a linear equation? So let's say I gave you that point right there. I said, well, graph the line that runs through that point. Well, I mean, you could do that, right? But you could also do that. And you could also do that. And you could also do that. I mean, you're getting the idea, right? How do we know what equation is going to be represented there? Well, the problem is we don't. But what if I said there's that point, but it's also going to run through that point? Well, now, if it's a line, it's going to run through both those points. Can I connect them? That was really bad, but you get the idea, right? Yeah, I can connect them because now I have 2 points. And I could continue it on this way, and I could also continue it on this way, and so on and so forth. And then I would have, multiple points that the line is on. And so that's what we're getting at today. We're going to talk about intercepts. All right, so what are these intercepts? Well, we have 2. One's an x-intercept, and it's where a line is going to cross the x-axis, and then we're going to have a y-intercept, and it's where a line, that same line, crosses the y-axis. Again, this is our x, and this is our y. So if I were to draw just some arbitrary line, like that, and I said, okay, well, tell me what the intercepts are for that equation. What would you tell me? And I know it's not perfect exact, but boy, the x-intercept, well, where the line crosses the x-axis, well, here's the x-axis, and boom, it certainly looks like it's crossing right there. So I would say the x-intercept is, you could either write it as -2, or you could say it's the point -2, 0. Now, what about the y-intercept? Well, it's where the line crosses the y-axis, and it sure looks like it's crossing right there at 3. So you could say, well, the y-intercept is 3, or it's at the point 0, 3. Left or right 0, and then up to 3 to get right there. All right, so try this one real quickly. All right, so what are the x and y intercepts? Well, the x-intercept certainly looks like it's there at -4, so I'd say the x-intercept is at -4, or you could say -4, 0. And the y-intercept, well, the y-intercept is where? Well, he's right there at -3, or you could say it's the point 0, -3. All right, so now let's work on starting with an equation and then finding the intercepts from there. So I gave us the equation 3x minus 2y equals 6. And we want to find the x-intercept and we want to find the y-intercept. So how do you do that? Well, there's a method. When you want to find one intercept, you make the other variable equal to 0. And so what does that mean? Well, if I want to find the x-intercept, I'm going to rewrite my equation, but I'm going to make y equal to 0. Okay? And so what we'll do is we'll rewrite as 3x minus 2, not times y, but now times 0. And that equals 6. And now what you see is that since the y is now gone, we have 3x minus 2 times 0, which is just 0, so I don't even really need that, is equal to 6. 3x equals 6. That's not any special linear equation. That's just an equation we've been solving for years now. And so all I would do is divide by 3 and divide by 3 to get x by itself, and then x would equal 2. So what's my x-intercept? Well, it's 2, okay? Or it's the point 2, 0. Now what about my y-intercept? Well, again, you want to make the other variable equal to 0. So if we're finding the y-intercept, I want to make x equal to 0. So I'm going to rewrite as 3 times not x, but 0 now, minus 2y equaling 6. So what's 3 times 0? Well, it's 0 minus 2y equals 6. And I don't even really need the 0, so I could just write -2y equals 6. Divide by -2 and divide by -2 to get y by itself. And you get y equaling -3, or you could say it's the point. If it's on the y-axis, it's going to be 0, -3. And so there are your intercepts right there. And so what we can then do is we can actually graph that. So let's go ahead and do that. All right, so if I'm graphing the x-intercept, it's going to be on the x-axis at 2. Okay, so I'm going to go to my x-axis and find 2, and it's right there. I'm going to make a point. And then my y-intercept is going to be -3, so I'm going to go to my y-axis and go to -3. And it's going to be right there. And so then what can I do? Well, again, like we said in the beginning of the video, you only need 2 points to graph a line. So I'm just going to connect them with a line. Oh, it was so close. Sometimes I get it right away, but it's super rare. But when I do, I love it. So anyway, there you go. You've graphed an equation after not making a table like we've learned in the past, which is valid and does work. But you started with the equation, you found the intercepts, and then you graphed. All right, so let's say you are going on a canoe trip, all right, and you are sitting in your canoe and you're about ready to go 12 miles, okay, down the river. So here's you in your canoe and you're sitting there ready to go. So you have 12 miles to go. So obviously if you're sitting in a canoe, you got a couple options. One, you can just sit there, right, and you're going to drift. And eventually you're going to drift downstream and you will make it all 12 miles. So now let's say that the drifting speed, so I guess the speed of the water, right, because you're not paddling if you're drifting, is 2 miles an hour. But you could also not be lazy and you could paddle, right? And so they'd say if you're paddling, you're going to go 4 miles an hour. So, I mean, think about this. If you drifted the whole way, you would eventually get there. But you could also paddle the whole way and you would get there a lot faster. But couldn't I do a little bit of drifting, a lot of paddling? Or a lot of drifting and just a little bit of paddling? Maybe somewhere in between? Yeah, I could, right? So what we're going to do is we're going to develop an equation, first of all, and then we're going to graph that equation, and that equation on our graph is going to show us the different combinations of time that you spend drifting and paddling that's going to get you all the way downstream, and it's going to show us how long it will take to get downstream if you paddle a lot but only drift a little, or vice versa. All right, so let's think about this thing. We've got to go a certain distance, and the question is, well, how far is that distance? Well, this is like a total, so when I hear total, I need to think equals that number, so that total distance we have to go is 12 miles. But the question is, how do I go that 12 miles? Well, for one, I could paddle at 4 miles per hour times the number of hours would tell me how long it's going to take me to get 12 miles. So I could do 4 times, and I'm going to use x, so paddle speed here, right? So the time I'm paddling is going to be represented with x. 4 miles an hour times the time I spend paddling. But also, I could add to that, and I'm going to do this in red so we can kind of differentiate here. I could also drift. Now, if I drift, what am I doing? Well, I'm just sitting there. Now, I'm still moving at a speed, though, of what? Well, 2 miles per hour, and then I multiply that by the number of hours that I drift for. Now, I'm going to use y here because x stands for hours paddling, y stands for hours drifting, and they're different types of things, different speeds, so I use different variables. So I know that this equation here is accurate because it's going to be 4 hours times the number of hours I paddle plus 2 hours times the number of hours that I drift for has to give me my 12 miles. All right, so let's go ahead and graph that. And you might be going, well, how do I graph that? Well, think back. I mean, what have we been doing today? Intercepts, right? I need to find my x-intercept and my y-intercept. So why don't you take a second, and if you don't remember right now, look at your notes, refresh your brain on how to find the intercepts, and do that and play when you're done. All right, so I remember if I want to find the x-intercept, I make y 0. So I'm going to do 4x plus 2 times 0 equals 12. Well, 2 times 0 is nothing, or 0, so I really have 4x equaling 12. And if I divide by 4 and divide by 4, I get x to equal 3. So what is 3 then? Well, 3 is my x-intercept, so let's save that for later. Now I want to find the y-intercept, so I make x equal to 0. So now I have 4 times 0 plus 2y equaling 12. Again, I'm just rewriting this original equation that we came up with. 4 times 0 is 0, so I don't need it. 2y equals 12. Divide by 2. Divide by 2, you get y to equal 6, and that's my y-intercept. So my x-intercept is 3, my y-intercept is 6. Let's go ahead and graph this thing. So now, before I graph it though, let's first of all think. Am I drifting for negative hours? Am I going negative distance? Anything like that? No, I'm not. So I'm just going to use one quadrant, okay, or the first quadrant out of the 4, okay? And let's think about it. What did x stand for? And what did y stand for? Okay, so this is my x-axis. What did that stand for? Well, we had 4 times x. Well, what was 4? 4 was the paddle speed. So 4 miles per hour times x, which is the, well, number of hours I'm going to paddle for. So x is the, and I'm going to, let's see. Can I move this? I don't know if it'll let me move it. Yes, it will. Awesome. So our x-axis is going to be the hours paddling. Okay. Now, what did y stand for? Well, in our equation, we had 2 times y. Well, what was 2? 2 was the drift speed, so 2 miles an hour times what? Well, the number of hours you drift for had to get me 12. So y, the y-axis, is going to stand for the hours drifting. Okay? And so then what I'm going to do is I'm just kind of rough sketching this, but do my best to keep all things equal. I'm going to graph my intercepts. So what was my x-intercept? Well, it was 3. So where is 3 on the x-axis? It's going to be right there. And what was my y-intercept? Well, it was 6. Okay, so 6 is going to be 1, 2, 3, 4, 5, 6. Now, what am I going to do? Well, I'm just going to connect them with a line, of course. Okay. Whoa, that's not a line. That's a line. If I can get it. Oh, it's pretty good. Pretty good. Okay, so there we go. So there's my graphed equation. But what does that tell me? Well, it tells me a couple things. All right. Well, number one, it tells me that, hey, if these are all equal to 1, so 1, 2, 3, and 1, 2, so on and so forth. Right here is 3. So 3 hours paddling. Because that is on the line, what it tells me is if I paddled for 3 hours, I would go my whole distance of 12, right? So, think about that. I got to go 12 miles. If I paddle for 3 hours and I go 4 miles an hour, right? Well, after 1 hour, it's 4 miles. After the second hour, it's 8 miles. After the third hour, I'm at 12 miles. So, duh, it makes perfect sense. Okay, same thing with drifting. It's up here at 1, 2, 3, 4, 5, 6. If I drift for 6 hours and I paddle for 0 hours, right, because 0 would be right there, I'm going to go the whole way. I'm going to go all 12 miles. And that makes sense, right? Because, well, if I drift at 2 miles an hour and I got to go 12 miles, it's going to take me 6 hours to do that whole distance of 12 miles. But the awesome thing is that there's other possibilities in here, right? And so what I actually know, because I've done this problem before, is right there at 2, 2, the 2, 2 is on that line. Okay, so what does 2, 2 mean? Well, the first 2 is the x, the second 2 is the y coordinate. So 2, 2 means 2 hours paddling, 2 hours drifting should get me my 12 miles. Now I can double check that by rewriting my equation and plugging in 2 both places because we're using the point 2, 2. So 4 times 2 plus 2 times 2 should get me 12. 4 times 2 is 8, 2 times 2 is 4, and last time I checked, 8 plus 4 equal 12, right? So we could do 2 hours of each and go the 12 miles. All right, cool. Well, that's all I have for you guys on this video. Again, remember to find the x-intercept. You make y 0 and solve to find the y-intercept. You want to make x 0 and solve, and I will talk with you more about that in class. See ya.